Welcome to the world of data structures. Our today's topic is doubly linked list deletion. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, today we are going to learn about the deletion in doubly linked list. But before that, let's just revise the concept of doubly linked list. As we know that doubly linked list contains three things. One is data and the two different pointers are there. The data is known as the info, we can say, and the pointers are like LPTR and RPTR. If we have this particular doubly linked list, then the 40 is nothing but is a node of the doubly linked list because it contains two things, one 40 and two different pointers, one on the previous side, one on the next side. The previous side pointer is known as LPTR and the next side pointer is known as RPTR. Students, the L and R both are the pointers which is pointing to the leftmost node and the rightmost node of the doubly linked list respectively. Next, if I told you that the LPTR of L, that means the left pointer of L is pointing to null and the right pointer is R is pointing to null. What happens is that when the doubly linked list is empty? Students, when the doubly linked list is empty, then both L and R both pointing to null. Fine. So let's move towards the algorithm of doubly linked list deletion. So students, here in the doubly linked list deletion, we have the condition or situation that here we need to delete a node whose address is old. Okay, old, that means the address, like we take a new, we take L, we take R, same like that, the node is pointed by a pointer whose name is old. That means the address is contained in the pointer old. Fine. So we need to delete a node whose address is pointed by old pointer. So let's start the doubly linked list deletion. For any deletion operation, students, here we have the procedure doubly delete. We have L, R and old with us. L stands for leftmost pointer, R stands for rightmost pointer, and then old, the node which we want to delete, old is that address. Fine. Now let's start with the conditions. What to do in the deletion? Always remember, when we talk about the deletion, we need to check the underflow condition, students, right? So here the underflow goes like this: if my L pointer L is equal to null or R is equal to null, you can write anything, right? If my L pointer is equal to null or R is equal to null, then just write underflow over there and write return. Students, if you write L is equal to null, then it's also fine, you can write it. Okay, now what are the next? The next condition is that if I want to delete a node, okay, but if there is only a single node in a doubly linked list. Students, when it happens like a single node in a doubly linked list, when there is a one node at the time L and R both pointing at the same node. So the condition can be like this: if L is equal to R. L is equal to R, that means if L pointing to R and R pointing to L, the location of the node is similar, then only one node is there in a doubly linked list. So what to do? Let's take a look. See, if this is my node that contains 10, this is a single node, that's why it's LPTR and RPTR both pointing to null. And this is my L and R both pointing at 10. Now what I need to do is I just need to make a list empty because I want to delete 10. So what happened? In empty linked list, in empty doubly linked list, L and R both pointing to null. Yes, so I just need to do the same thing. So here I can make L and R to null. So here it is, both my L and R pointing to null. Then the node is deleted. So this is how you can delete a node when there is a single node in doubly linked list. Now, next step. Students, the next condition with us is that if we want to delete a node which is a leftmost node, that means old is equal to L. So let's draw a figure of a doubly linked list. Here it is my doubly linked list. Here like a 40, 10, 40, 23 and 53, all values are there. Right now my L pointer is pointing at the first node. Okay, I want to delete the same. That's why old is also pointing at the that node. Fine. So students, as my linked list starts from the first to null, okay, in doubly linked list starts from left to R, left to right, L to R. So when I move L from one node to another node, the linked list size is that only. That means my first node is automatically deleted. It considered as a out of the family of the linked list. That's why I'm going to do is just a one step, like L, move L to the RPTR of old. So if this is old student, then the next node of the 40 is known as RPTR of L or RPTR of old. You can write anything whatever you want, because right now L and R both are pointing at the same situation. Okay, so I just need to write only one statement, and that is L arrow RPTR of L. So here my L pointer is moved from 40 and go to 10. Okay, so this is how I can remove my L, or this is my how repeat. So students, this is how I can remove my leftmost node. So it is gone. Now, what about the next condition? So students, now the LPTR of L becomes null. Okay, because there is no node on the left side of the 10. Now, next condition. The next condition is if I want to delete a node on the right side. Okay, so if I want to delete a node on the rightmost side, that means I want to delete R. So same as L, I need to do perform steps over here. Okay, so let's start. So what happens here? R with R students, I need to move R to LPTR of R. I need to move R to LPTR of R. So here again, this is 53 is known as R and 23 is known as LPTR of R. So what I need to do, I just need to write a single statement that is known as R arrow LPTR of R. So R is gone from here and set on the 23. Now, to remove this, I also need to break the right link of 23. It means the RPTR of R pointing to null. Okay, so here it is, my 23, right side of the 23 to 53 gone. Now, what is the last step? So students, what is my last situation? My last situation that if my pointer is not on the left side, not on the right side, but in the middle of the linked list. See, right now my old pointer is pointing at the 47. Okay, so I want to delete the 47. So students, what I need to do is I need to connect the left link of the 47. See, the left link of the 47, that means the right link of 23. The right link of the 23 directly to the 53 and left link of the 53 directly to the 23. Okay, just check it out. Just imagine a situation, if I delete 42, what happens? The right link of the 23 will going to be connected on the 53 and the left link of the 53 is going to connect on 23. Fine. So let's do it. Before connecting any link students, what we need name of that nodes. Okay, we know 42, the name of the 42 is old. Then what is called the left side of the 42? LPTR of old. And what is called the right side of the 42? RPTR of old. Fine. So our task is done. What to write in the else condition? So what we need to do students, see the right link of the 23. Okay, right link of the 23. Just focus on the animation over here. Just focus on the animation over here students. See the animation over here students, that the right link of the 23, the right link of the 23 is going to be connected on the 53. So what is the name of the 23? LPTR of old. I want to connect right link of 23. That means RPTR of LPTR of old to RPTR of old, because the right link of 23, 23 itself means a LPTR of old. So right link of 23 is going to connect on the right link of old, that means 53 itself. Fine. Now, what to do next? See, now my right link of the 23 is gone and connected with the 53. Now, let me start with the next step. Now I want to connect the left link of 53. Okay, now I'm talking about the left link of the 53. So students, what is the name of the left link of the 53? What is the name of the left link of the 53? The left link of the 53 is known as LPTR of RPTR of old. Okay. So here the left link of the 53 is known as LPTR of RPTR of old, which is going to connect on left side of the old. That means 23. So we need to write LPTR of RPTR of old to LPTR of old. Such like this, the all links are connected, and then we can directly remove the 42 from here. Fine. So the last step is restore old. Students, as in doubly linked list, we use insertion at the time like new is equal to node to get a node from the availability stack. Same like that, with the restore function, we can move our node to availability stack back. Okay, so that's it to all about the doubly linked list, where we can say that we learn about the how can we delete the node from a doubly linked list, how the doubly linked list can perform, how can we insert a node in a doubly linked list, what do we mean by LPTR, RPTR, L and R. And do not forget to remember that to insert, when you are inserting something, just assign the name to all the nodes. Any operation in the linked list, just assign the name to that nodes. It will be very much easy to you to get the idea about which link is connected to the which one. Fine. So if you have any doubt, then please feel free to ask me. Thank you so much.